All right, so we just saw what an ANOVA was. We learned about it. How do we calculate it? First, let me do some clarification. In psychology, we only use the ANOVA when we have three or more means. My second clarification, psychology requires us to use effect sizes for every single analysis we do. And the effect size that we will use for the ANOVA is called a partial eta squared. Now, partial eta squared simply tells us the percentage of total variability in our data file that is due to our independent variable. The percentage of variability that is not due to our independent variable is due to error. So you can have an eta squared of 0.01. That means 1% of the variability in your data file is caused by your independent variable, and that is small. 0.06, 6% is caused by your independent variable, and that is medium. And 0.14, 14% is caused by your independent variable, and that is large. There are two types of one-way ANOVAs. One way means one independent variable. Okay, ANOVA means you have three or more conditions. Between subjects means that you have participants randomly assigned to one of the three or more conditions. Within subjects, one-way ANOVA, one independent variable, three or more conditions. Within subjects means that every participant participates in every level of that independent variable. Okay? You should know that. I'm not going to spend any more time on that. Let's do one example. We have a between subjects one-way ANOVA. We know that it's a between subjects because participants were randomly assigned to one of three conditions. They ate candy, pizza, or salad, and then they reported how happy they were. I made these data up. They are not real. They are funny. When you enter data into Jamovi, you are going to do it one participant per row. So this row represents one participant's data. You can see how the data file would be set up. In this case, I am starting with my data in table form, and all I have to do is copy and paste my data into Jamovi. Now I have to make sure my variables are specified correctly. Double click on A, call this participant. This is an ID variable. Because it's just a participant ID, that's the correct specification. Double click on my B variable, or really just click. This is my food condition independent variable. What type of variable is it? Well, it's not ID, it's not a participant ID. It's not numerical, so it can't be ordinal or continuous, so it must be nominal. Nominal just means there are different names that define the different conditions. These different conditions don't differ on any quantity, so they're nominal. And then finally, my third variable is happiness scores. Okay? Now, these are numerical numbers, and so we have to choose between ordinal and continuous. To figure that out, you got to say, well, is the difference between 1 and 2 the same as the difference between 2 and 3? So in this case, a person that scores a 2 on their happiness score is 1% happier than a participant who scores a 1. A participant who scores a 3 is 1% happier than a participant who scores a 2. So yes, the difference between a 1 and a 2 is the same as the difference between a 2 and a 3. So it's continuous. Really, the only cases I can think of that are ordinal are like military ranks. There are other cases, but really the ordinal one is used very rarely. So most of your numerical variables will be continuous. Before we do anything, click these three dots at the top of your program and change your number format to 2 decimal places. Not 3 significant figures, whatever. 2 decimal places. In psychology, we report our statistics to 2 decimal places. And neuroscience as well. If neuroscience is different and y'all report them to 5 significant figures, nobody told me that. So now everything's set up. What do I need to do? I have the data in the data. What do I need to do? For me, you're going to calculate your descriptives and statistics for every single test that we do. So this is going to be a consistent process. Number 2, get your p-value and your effect size. Number 3, graph your results. Number 4, interpret your p-value and effect size. And number 5, write a statistical sentence. So let's just do those steps. For this type of problem, calculate your descriptive statistics, explore descriptives, Split your data by your independent variable because I want to get different means and standard deviations for each condition. Click statistics. Only choose mean and standard deviation. And now go ahead and, oh, I put participant in there. I was like, what's going on? You got to put your DV in there. And now you can see that you have means and standard deviations for your three conditions. And what do we see? It looks like people that ate candy are happier than people that ate pizza, are way happier than people that ate salad. Our standard deviation, remember, that tells us how good our estimate of the mean is. It looks like the salad estimate is the best standard deviation, suggesting that the scores were the closest together, right? These scores only differed from the mean on average by 6.5 points on the scale. This is a percentage scale, so they only differed from the mean of 8 by 6.5%. In terms of the pizza liking, that's a very high liking of 80%. Well, not liking, it's a very high happiness rating of 80%. But scores on this happiness variable differed on average by 26.29%. Same thing for candy, just 16.92%. All right, we look at our descriptives. Do we see anything? Well, it looks like, the impact of salad on happiness is more consistent than the impact of the other two foods on happiness. All right. But I just had to get my descriptives. I'm just looking at them. I don't have to do anything but get them. I'm just thinking about them with you out loud. Second step, get my p-value and my effect size. How are we going to do that? I'm going to click on ANOVA. I'm going to click on ANOVA again. Don't click on one way. Click on ANOVA. All right, my dependent variable is happiness. My independent variable is food. We can see that it automatically now gives us the p-value, which is what I'm after. The other statistics you learned about already, we'll talk about them in class, but right now, the null hypothesis was that these three means are the same, right? The probability of obtaining data like we obtained right here, all this stuff, if the null hypothesis were true, is less than 0.4% likely. The null hypothesis is not true. These means are different somewhere. I just don't know how they're different. That's important. We'll talk about that in class, okay? So I have my p-value, right? I don't know which means are significantly different from each other. That requires another test called a post hoc test. We're going to leave that for class. I now need to calculate my effect size. My partiality squared is 0.85, so I have a significant and a large effect. That is very good. Finally, number 3, you want to graph your results. In order to graph your results, you click into estimated marginal means. You plug your independent variable over into your estimated marginal means. You change your error bars to standard error. And you know what? You don't have to do this, but I'm going to do this because I think it's cool. So if you look, it shows us our different data points. And you can see that like the salad data points are closer to each other. And I think one must be right at the mean. I can't see it, but you can see like our salad points are all kind of around here. But our happiness points for pizza, there's a wider range there, and that corresponds to a larger standard deviation for pizza. Look at that. And look at these. There's a pretty wide difference here from the mean, right? But you can see that has a little bit smaller standard deviation than the pizza, right? You can see where that's coming from. Anyways, that's just me having fun. I want my students to make graphs so that you all can see, oh, it looks like eating junk food is making people happier than eating salad. Definitely love that result. I'm going to eat more junk food as a result of this. This is made up data, but I'm just having fun with it. And so now we've done our major 3 things, like our major 3 statistical calculations. And it took us no time at all. I'm going to select all. So I'm right-clicking, selecting all, copying, and just for my homework, I'm going to paste it in there. I have everything I need. I think from now on, our homework, we should just do it like this in Word because now we have to interpret our results. So our null hypothesis was that our 3 population means were the same. Right? My p is less than 0.05. So I'm going to say, okay, my 3 population means are not the same. I don't know which means are different. That's another test called a post hoc test. I'll show you that in class. Okay? But right now, I see that. What's my effect size? This is a large effect size. So essentially, we know that we have a significant difference, right? And we have a large effect size. Now, I'm just going to flip this on its head for a second. What if we had a non-significant difference in a large effect size? Well, in that case, we still know nothing. That non-significant difference is step number 1. And then our effect size tells us how large the effect was we found. So in this case, we know the null is not true. Well, we might be wrong, but very unlikely for that to be wrong. We're rejecting the null, saying the null hypothesis is not true. These 3 population means are not the same. That's our inference. We're making an inference about population means. And we're going to infer that this difference is a large difference, that these means are drastically different from each other. That's it. Okay? And now we have to write our statistical sentence. I no longer need the Jamovi up. So we can summarize this entire finding into one sentence. A one-way between subject ANOVA, you always say what test you ran, revealed that food consumption, my independent variable. And then I'm putting all of my means and standard deviations right after I mentioned the independent variable. Caused a large and significant impact on my dependent variable, happiness ratings. Now, yours wouldn't be in red. I'm just showing you what you need, right? You need to state that you ran this test. Revealed that can be replaced with other words. Food consumption, referring to my independent variable. I wrote caused, sometimes you might say was associated with a large and significant. Large is my effect size. Significant is my p-value. Impact on happiness ratings. Then I put my F statistic. I'm going to go ahead and copy this down here just so you can see where this is coming from. Okay? But my F statistic with my degrees of freedom due to my independent variable, my degrees of freedom due to error, okay, equals my F statistic, my p-value, and my partial eta squared. You are done. That's all you need to do. We have now solved one of our problems.